the use of drones to quantify those post-harvest residue is a thing like that can be real or realistic. So we will dig a little bit into this approach and see how it goes. So a little bit about myself first, even though Simon already introduced me. So I did both my bachelor and master degree in forest science in Italy. But I visited also different, let's say, other forest countries, like especially Canada and Sweden, but as well as Norway, Czech Republic, and Austria. And I've recently been to South Africa. I finished my 2 month stay like almost a month ago. And I started my PhD in Italy in this last October. And I'm currently working in the field of precision forestry and post-harvesting biomass management. And I've got a great passion for hiking, trekking, and sports in general, which I think have helped me to going along with this path. And now, this is a brief outline of the presentation I will do. So I will introduce a little bit about the project, the KFOC. Then we will dig a bit, well, like why looking in for like forest residues, and then a little bit more at the variables in play, and then a bit more specifically
there is that little deep spot
in the drone approach, and then have a look at some preliminary results from my research so far, and then we will address a bit about what's next with this challenge, about the use of drones, and specifically into the estimation of woody biomass. So the Care4C, as Simon already said, is a European project. As a carbon smart forestry under climate change. The challenge that forestry needs, especially in this time, is to contribute to low carbon emitting society. So while as like the forest sequester the carbon, they also emit the carbon during forest operation. And then, so the main aim of the project is to substantially like expanding the knowledge about carbon sink and forest growth, and then the carbon source by forest operation to enable this carbon smart forestry management style. So the goal is to reduce the emissions, or to better account the emissions provided by the forest operation, in order to provide a good balance in our forestry activity. And then why looking at forest residues is because like they are often called waste. Even if you're not an academic and you see a picture like this, the majority of people will think that the site is not cleaned, is not beautiful, is not good, doesn't look good. There's a lot of waste on the ground. But actually, like forest residues in this case, they have a lot of untapped potential, because they provide cover for ground against real erosion and overflow, or whatever other phenomenon of hydrological erosion. They're a major source of nutrients for both micro and macro. So let us think about like the carbon, the whole nitrogen, and all the other nutrients. They build habitats for insects and arthropods, but also for fungi. There are main actors in all that soil regeneration dynamics. And then they serve also as source of bioenergy production, which is a thing that is getting like with a higher attention now. And there are also many more other aspects about residues, but I'm not really digging into them. But just to give you an idea where the interest is now in this field, and we know so very little about it. The variables at play when we talk about residues are mainly related to residue regime. And the three main fields of variables are related to the working system. So like how those influence the quantity and quality of residue. And then we might have like cut to length system with highly mechanized machine working, like harvesters, forwarders, but as well like excavator with processing head. Then we have full tree systems that, especially in our setups in Europe and in the Alps, are mainly driven by chainsaw operators and cable crane systems. And those are a little bit less impacting on the residue, on the sense that they are extracting all of the residues outside to the road, whereas the cut to length, they leave the residues inside the forest. And of course, this is the major variable when we talk about the quantity. But how about the quality? So it depends also on the different tree species that we might have. So in my recent experience in South Africa, I visited different like eucalypt plantations, but also some pine plantation. But in Europe, we mainly have, especially in Alps, like other conifers like Scots pines and spruce, but as well like other like deciduous like the beech. Then we have some other climatic and environmental variables, mainly like temperature driven or like the precipitation, but as well like more complex ones like related to soil interactions. So as I said, like all that biota related to an environment related to the insects, the fungi, as well as other dynamics going on, as well as also like the soil building. And then let me give you a brief overlook at what is this drone approach that you have subscribed and so many to let me talk to you about this. So before talking about drones, so drones are part of the UAVs family. So unmanned aerial vehicles that have been widely used, especially in the last decades or two, and especially we can relate to those like in agriculture for precision farming. Some of the applications that we see nowadays in the forest sector are related to previous application in agriculture and precision farming. But as you see here from the summary, there are really a lot of applications that can be achieved with the use of UAVs. We can relate mostly to the last one, like surveying wildlife, forests, and natural resources, but as well like agriculture and field monitoring. But as you see, like the applications are like endless. In like this is just like few of the many that are already in place, but we're not even looking like what the research and development is doing for many companies. So this is just a bit of a summary to understand what is this drone approach and why is it working. And is it working because drones are actually versatile instruments that I can be easily used in the most diverse situation. And the summary before explained to you really well, I think. And they provide a good compromise between what's the detail and the coverage of an area. I put here like another little scheme that shows that manual measurements that are represented by the ruler can be those like very accurate, but they have like limited coverage. Whereas on the other end of the spectrum, we have satellite images that can like have a very wide coverage of an area, but very low detail, so very coarse resolution. But all of these are perfect tools, and especially the drones, when we want to talk about precision forestry. Precision forestry is actually the use of tools and technology to collect all this data to make decisions for site-specific management and provide more accurate or realistic information that they actually currently use the resources. So for example, with all the field measurements, we are talking about scales of detail of millimeters and centimeters, which is very accurate because it's what's actually in reality. But the scale in coverage is very low. We can cover some linear meters or few square meters. Whereas with the drone, we have this a bit of a compromise between scale and coverage. And since they can cover up few hectares with single flights or with multiple flights, and they have still resolution at centimeters level on the ground. Whereas with satellite images, yeah, we can cover larger areas of several hectares or square kilometers or even linear kilometers, but then the detail is very coarse. The resolution of our pixels of the single images can be on the scale of meters, tens of meters actually, or kilometers. So you see now the drones in general UAVs, they provide quite high coverage, as I told, like some hectares, and the detail can range from centimeters to millimeters according to the flight, to the height of the flight. So as you see that the drone approach in this sense, like especially in forest management, can help us to find a good compromise between like field measurements that can take up to different hours or days of measurements, and on the other hand, satellite images with wider coverage. So related to my research topic, what we did was like we transformed we went from the drone images to this residue detection and classification we are now working on the to extrapolate the residue volume, and I will show you just a little approach and a little experiment we would try to do. And then what's the final step that we haven't achieved yet, but we are working on it, we're starting to work on it, is this carbon stock accounting and site fertility based on the nutrients left on the site by the residues. And this is actually important for the Care4Sea project because we want to do these very high detail carbon emission accounting, and the residues are actually carbon stocks that stays on the ground or can be used for many other applications. So just a bit of technical things. So from the drone images, we were able to extrapolate information related to the surface, especially terrain variables, such as the roughness and the slope and other variables that we were able to extract it. And then from the orthomosaic photo of the area, which is the all collection and stitched mosaic of the all pictures taken by the drone, we were able to extrapolate the red, green, and blue data from them, also to calculate some support variables, such as the mean, the standard deviation, classic statistical variables. And then also from some manual measurement on the photo, we were able to extract some residues information. And then just as a control, we were also manually sampling the residues on the ground. Then we fit all this information on the classification model and then use the field measurements as a control and comparison of our measurement. So far, the thing has been easy. When we put all the information together, now we get this kind of result. So this is a eucalypt site that we visited during one of the trials. And as you see, the surface is almost close to 1 hectare, which is great for comparison and as a case study. So the estimated volume per hectare, or I should say mass per hectare, megagrams per hectare of the residues in this portion of the compartment is roughly 41 megagrams per hectare. The estimated volume from the UAV, as a very rough estimation using one of these tools in QGIS, which I'm sure you're very familiar with, gives an estimation of 46 megagrams per hectare, which is very close actually to the estimated by the field measurements. And this is just like a formula that takes into account the difference in height between the base layer and the actual height perceived by the drone, so on the top. And then there are some other conversion factors related to transformation of the content of the concentration from cubic meters over square meters to megagrams per hectare. So passing from volume to a weight of a mass, and then from a surface unit to another, which is really super easy. But so the portion took into account is just like this central one, where you can really clearly see the rows of residues. This site especially was manually harvested, and the residues were manually placed in rows. So we can say that there is no machine impact in this site, and it was quite a nice site to sample, and I would say, and a very special one, because on this one we decided to start this whole measurement and trial. So it was actually one of the simplest ones to do it. But actually, what's interesting is that the classification algorithm, and then you see the results actually here on your right. This is actually the results provided by the whole classification algorithm. And you can see with a comparison of the area that I was mentioning before, what kind of elements are picked up by the classification algorithm, where that classified each pixels inside the image as one of the objects that you find in the classification legend here on the ground. And then you see he's able to pick up the merchantable timber that is still left inside. And of course, there is some misclassification with the coarse wood debris, but it's because the material is the same, and the kind of reflectance of the material is almost the same, since it's eucalypt timber debarked. So the result is quite nice, and I think it's quite useful, and it's very easy to do it now. with the algorithm we are working on, and doesn't really require any external data that the drone images so far. So, and it still provide a good result. As I said, it can almost clearly pick up the ground between the rows, and then it also picks up the rows with this difference in height. Then is able to classify everything else according to the RGB. And those are just the preliminary results, because I come back from South Africa last month, in a month time, so I was only able to process this data. And then, so what's next? So based on the outcomes that I showed you, that are also the main outcomes of this piece of research, the approach that I show is a solid way to generate classified images related to residue. And they provide also a solid base for volume estimation, for better volume estimation, without relying on the QGIS, because there might be some ditches in the ground that were not picked up from the aerial image, for example. Then they unset the balance of the volume. This kind of approach can help in planning the retrieval operation for both coarse wood debris and fine wood debris, especially now in the hubs. There is this interest into using this type of material for bioenergy production. So a company might be interested into knowing where these residues are and plan the retrieval with the machine or even with the ground crew. And then this contributes to the general understanding of forest residues and their potential roles on sites, especially with the carbon and nutrients regeneration. And then might help also some other companies, for example, to reduce the amount of fertilizer used in plantation or in other forest setups. The next steps in general with drone application, as you see here in this little other summary, the application of drones in forestry are basically endless. As they say, the sky's the limit, and we're talking about drones. I mean, it's the perfect phrase to use. Some of these actually applications have been already developed in agriculture, and then have been applied, or they might be applied in forest and in plantation environment. For example, the mapping of forests is one of the most used probably right now. And then forest management and inventory detections. Why not 3D mapping to understand what's the status on the health of our forest? And then to easily detect and manage a disease, such as, like, now we are having a lot of problems in the Alps with bark beetles on some areas that maybe we're not really able to access because we lack of forest road. One possible application would be to fly the drone and to assess what's the actual status of that population. But this is just some examples, and I mean, like, your imagination is the only thing that can limit the outcome of this endless drone application in forestry. Thank you for your attentions, and if you have any question, please feel free to ask or to put them into the chat, so we can have a very nice discussion together.